Okay, so another question where we are having to sketch this curve after figuring out the nature of the stationary point. So Eg3. So we start with x to the 4 plus 4x cubed minus 6. And this is a process you were well practiced at in AS. So first of all, we need the stationary points. So stat points occur at dy dx equals 0 when the gradient is flat. So dy dx will be 4x cubed plus 12x squared, and then the minus 6 has gone. So that's dy dx. When that equals 0, (4x cubed plus 12x squared) equals 0. I can take common factors of 4 and x squared, leaving me x plus 3. Just check, multiply that back out. 4x cubed plus 12x squared. So either x equals 0 if 4x squared equals 0, or x equals minus 3 coming from that bracket. We need to find the stationary point coordinates, so I need the corresponding y's, so I'm going to substitute both of those back into equation 1. So in 1, if x is 0, y is negative 6, so I've got a stat point minus 6, 0. And for this one, if we go back to our funky calculator and we store negative 3 in x, then we can just type x to the power of 4 plus 4x cubed minus 6, and we get minus 33. So the other stationary point is at minus 3 comma minus 33. So those are the coordinates of our stat points. Now we need to determine whether they're maxima, minima, or points of inflection. So to determine that, we need the second derivative. So I differentiate that again, and I get 12x plus 24. Now if we put the x as 0 into there, (24x). What have I done? Hold on. 12x squared plus 24x. So when I put x as 0 into there, I get the second derivative equals 0. Now if you remember from the table we were looking at on the previous page, you can see that if the second derivative is less than 0, it's categorically maximum. If it's greater than 0, it's categorically minimum. But it's ambiguous if the second derivative is 0. In order to be sure that it's a point of inflection, we need to differentiate a third time and make sure that when we substitute in the value of x, we get a non-zero answer. So ambiguous need d3y dx cubed, which is 24x plus 24. And now when we substitute x equals 0 into that, then the third derivative does not equal 0 because it equals 24. So therefore 0 minus 6 is a point of inflection. At x equals negative 3, d2y dx squared. So I'm going into this. So I've got x is negative 3 in my calculator anyway, so it's going to be 12x squared plus 24x equals 36, which is greater than 0, therefore a minimum will occur at 0 minus 6. No, it won't. At minus 3. Minus 33, sorry. So I got a point of inflection at 0 minus 6. I got a minimum value of at minus 3 minus 33. It's going to cross the curve, crosses y-axis at x equals 0, and we've already established that that is 0 minus 6. And we're not going to worry about where it crosses the x-axis because that's not going to be a pleasant one to calculate. So my graph then is going to cross the x-axis, y-axis, at 0 minus 6. So let's say that that is there. It's going to have a minimum value at minus 3 minus 33. So it's coming down, minimum there, point of inflection there, and then rising back up like that. So that's what the curve looks like. And what I'll take this opportunity to do is show you a really handy app you can download onto your phone, which is called GeoGebra. And what this will allow you to do, if I just knock my light off, is to actually sketch that and see what it looks like. So I'm going to input into that the equation, which is x to the 4, so x to the power of 4, move that along, plus 4x to the power of 3, move that along, minus 6. So you can see the curve having a minimum there at minus 33, minus 3, minus 33, and then we've got that point of inflection where it is turning from one gradient to another, and then that is it. You can zoom in and in and in, and those are the only turning points on the graph. So that's a really nice free app that you can use on your phone. And you can see now how very accurate my sketch is.